Hi, everyone. My name is Neha Kennard. I'm a PhD student here at UMass in the Computer Science Department, and I work on natural language processing, or NLP. Natural language processing is the area of computer science concerned with analyzing and generating human language. You're most likely to have encountered NLP technology in products like Siri, Google Translate, and ChatGPT. So I tried to interpret the title of this course in the context of natural language processing. And it was pretty hard because, of course, when we think about modern NLP, it's clear that we should be thinking of large language models like ChatGPT. But then when we come to the exploring part, it's a lot more confusing because these days almost everyone has explored this themselves, at least in the sense of interacting with a chatbot in some way. Another way to explore would be to look at all the technologies that go into modern NLP systems and understand what makes them tick. But this would take a few semesters, and I'd have to award you a master's degree at the end, which I'm not authorized to do. Honestly, 5 years ago, I might have said I wanted to explore with you all the cool things that can be done with NLP. But in 2023, the press is already trying to tell you that NLP can do everything, and sometimes even things it actually can't do. So I don't want to add to the AI hype. Now, where does that leave us? I'm going to share a story about NLP, and it's a historical story, so actually not modern at all. But while systems like ChatGPT are a new technological phenomenon, they aren't a new social phenomenon. There's a lot that I think we can understand about modern NLP by looking at parallel situations in the history of NLP. So let's set the scene. We're in 2023. Transistors, which most modern computers are based on, were invented in 1947, 76 years ago. The internet was invented 34 years ago, in 1989. And this story starts in 1966, so pretty early in the story of computers as a whole. In 1966, computers looked like this. They took up a whole room, and programming involved translating code into punch cards. Like, this is real old-timey. And yet, people were already thinking about artificial intelligence. Joseph Weizenbaum was a researcher at MIT, and he became interested in new ways for humans to interact with computers. Specifically, instead of programming languages, can we use conversation in human language to communicate with computers? And he immediately ran into a problem. Have you ever talked with an entity that has no history of existing in or sensing anything in the world? That has no experience, life, or memories whatsoever? Because that's what a computer is. What would talking to this kind of entity be like? Is it even possible? What would it mean? But it would have been a great breakthrough to make using computers more accessible to people without programming training. So it was worth it to try to make this somehow work. Weizenbaum came up with a clever solution. The computer had to play a role in which it would not be surprising that it appeared not to have any knowledge of the world. He elected to have the computer play the role of a therapist practicing something called Rogerian therapy. Here, the therapist is just supposed to reflect the patient's words back to them. So, for example, if you said to the therapist, I dreamt I was on a long boat ride, and the therapist replied, Tell me about boats. You wouldn't think, has he not heard of boats? But instead, that this is a wise and deep question asked for some important purpose. So, they built a program called ELIZA that was supposed to mimic a Rogerian therapist. Here's how it worked. Users would sit at a terminal, which was an electric typewriter hooked up to the computer. The computer was the one we saw earlier in its own room. Given the input from the user, the computer would determine ELIZA's response and then type it back on the typewriter, and the conversation would continue. And of course, this looks exactly like any chatbot today, except instead of the terminal screenshot shown here, the chat was being typed on a piece of paper. So, what did these conversations look like? This is one of the more famous conversations. All caps is what ELIZA is saying. So the person starts with, Men are all alike. In what way? They're always bugging us about something or other. Can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here. He says I'm depressed much of the time. I'm sorry to hear that you're depressed. Luckily, here, I'm not a good actor, so I was able to get close to the zero emotion and expression in Eliza's lines. Remember that these were typed out, so any emotion that was perceived in them was from how someone was reading them. Looking at this conversation in 2023, it may not look that impressive, but this was like before the internet. In 1966, if you were talking to someone, it's because they were in front of you or on the phone with you, and they were definitely not a computer. And many people had never even been able to use a computer before. And now all you had to do was type, and you could have this pretty reasonable sounding conversation. Naturally, this caused a sensation. One famous story is about how Weizenbaum's secretary tried it, and she allegedly asked him to leave the room to give her and Eliza some privacy. Weizenbaum was startled by this. The secretary had observed him writing the code for months, so surely she, of all people, would know it was just code. And what would it even mean to have a private moment with it? But people were really adamant about anthropomorphizing Eliza and believing that it had human traits like intelligence and empathy. Although it was first observed with ELIZA, this phenomenon has been prevalent in many different systems since, and it later came to be known as the ELIZA effect, the tendency to project human traits onto programs with textual interfaces. It kind of reminds me of how people tend to see faces in inanimate objects. The thing that really alarmed Weizenbaum, though, was the reaction from professional scientists and psychotherapists. People were enamored with the system, advocating that psychotherapists' work should soon be automated. They were saying stuff like, we could make therapy more efficient, running several thousand ELIZAs at once. Many people could talk with an attentive therapist at a low cost. And just to highlight, this idea of cost is something that will come back to haunt us. But Weizenbaum was aghast to see that psychotherapists were open to seeing their work as even possible to automate, as being pure information processing. He felt that they were discounting the significance of their own human presence in the interactions in their work. And these two questions, people's perceptions of machines' supposed human qualities and their willingness to have their work be automated, were two mysteries that preoccupied Weizenbaum for many decades after ELIZA was created. He wrote a book over a 2 year sabbatical exploring questions like what type of work should be delegated to machines? What is the difference between human and machine intelligence? And what happens when we use the metaphor of machines to understand human intelligence? He was one of the first thinkers about ethics in computer science specifically. For today, we're just going to focus on the first question. Weizenbaum became convinced that the way to combat the ELIZA effect was to explain the details of the technology. He said, once a particular program is unmasked, once its inner workings are explained, its magic crumbles away. It is revealed as a mere collection of procedures, each quite comprehensible. So to do this, he first published a paper in 1966 with all the technical details of how ELIZA was built. And in his book, he further dissected and demystified all of computing to the best of his ability, not just for a computer science audience, but for anyone who is interested. But while word of ELIZA spread like wildfire, and there were articles written about it in newspapers all across the country, these writings had a more lukewarm reception. Enthusiasm for the possibility of a computer program with human like qualities only grew, bringing us to where we are today. Somehow, these explanations were not sufficient to convince people that ELIZA was just code and not some kind of magic. My hypothesis is it was too early for this strategy. In 1966, explaining to someone that it's just code, it's just computers, that still left them impressed because computers still felt magical and impressive. They were brand new. But in 2023, programming is much more ubiquitous and much more a part of our culture. I think he would have been very successful if he tried to convince people today that ELIZA was just code and therefore not intelligent. So I'd like to do a little experiment together and show you a bit of how ELIZA worked. Don't try to read all of this. This 100 or so lines of code contains all the rules that ELIZA follows in order to determine how to respond to any input. So let's take a look at this snippet from earlier. If we're just looking at the core of how the ELIZA program responds to any particular input sentence, it's very simple. We start with a for loop, iterating over each word in the input. From left to right, men are all alike. For each of the words, ELIZA checks a number of rules to see if that word is a trigger. So for example, if you had typed in Sprechen Sie Deutsch, or do you speak German? The word Deutsch would trigger this rule. And ELIZA would respond that it only speaks English. So with this first sentence here, men are all alike, what happens is that you get to the word alike, and that triggers this rule. When someone says two things are alike or the same, ELIZA always asks them to expand on the similarity that they see. So here it comes back with saying, in what way? And I want to emphasize that this isn't a toy example. This is literally what the ELIZA system did. I copied it exactly from the rules in the published paper, and I just converted it to Python for readability. So it goes back to the user, and the user says, they're always bugging us about something or the other. This leads us to something really interesting that Weizenbaum pointed out specifically in his book. He thought that it was a reasonable assumption that whenever someone said the word always, they're making a generalization, but they're actually thinking of a specific incident. And this assumption was baked into the rules of ELIZA. So reading left to right, the word always triggers this rule, which prompts the user to think of a specific example. And again, this rule is directly copied over from the appendix of the 1966 paper. Another thing that Weizenbaum emphasized was that the rules he wrote weren't part of the code per se. They were data. They could be substituted, expanded, edited. They were an artifact he had made using his own creativity. In fact, you could look at this program as taking not just the user's words as inputs, but the rules as well, and then just procedurally going over the rules in order, checking each word against them. This makes the code even simpler, and it's something like what we have here at the bottom right. And I'm not trying to say that ELIZA isn't impressive. First of all, programming was a lot harder in the 60s, and the design of the rules is really clever. The priority ordering, the wording of the responses, the choice of trigger words, it's all actually makes things really believable. Data structures and libraries weren't available. So if you've ever used a dictionary in Python, he didn't have those. He had to write those from scratch. There's a lot to be impressed by, but these are all impressive programming feats, right? Like, is this program intelligent? Should we treat it as a person? Is it a substitute for a therapist? Now, we can't debate the meaning of intelligence right now. So I just grabbed the first line for the Wikipedia entry for intelligence. It says, intelligence has been defined in many ways: the capacity for abstraction, logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. So now that we're kind of conversant in for loops and if statements, I hope you'd agree that it's hard to argue that this little snippet over here exhibits any of these properties. So why am I telling you this story? There was a lot of media buzz about ELIZA in the 60s. And eerily enough, we're seeing the exact same thing play out with ChatGPT. In fact, you can almost see parallel headlines in 1966 and 2023. And that makes sense. They're so similar. There's new technology, whether it's Weizenbaum's code or this whole stack of things. There's a new accessible way of interacting, whether it's the electric typewriter or the OpenAI website. There's uncannily human-like output, which is even more uncanny for 2023. And of course, this causes breathless press coverage. Weizenbaum's life work was prompted by the response to ELIZA. So is there anything we can extrapolate from it and learn about what to expect with GPT? Looking at ELIZA code from 50 years in the future helped us to combat the ELIZA effect. Personally, I wonder, Will the ELIZA effect fade for this stack of technologies too someday? How will we view our current use of GPT when that happens? And this isn't a trivial question, because despite all the similarities, there are also important differences between ELIZA and ChatGPT. ELIZA's data was this clever script that Weizenbaum wrote. It had known baked in assumptions, like about what people mean when they say always. But ChatGPT's input is everything on the internet. It contains unknown baked in assumptions, including, for example, the beliefs and values of everyone on Reddit. ELIZA's output was predictable. Given a particular input, we can always tell exactly what its response would be. It'll never surprise us. But ChatGPT only works because it's probabilistic. ELIZA never really left the ivory tower. Different universities had their own implementations, but it was never really used for anything despite psychiatrists' enthusiasm. But with ChatGPT, governments and corporations all over the world are currently pouring billions of dollars into replacing workers with large language models. So let's talk about what happens when the ELIZA effect, where we might incorrectly estimate a system to be equal to human intelligence, coincides with all of these new circumstances. Earlier this year, the operators of an eating disorder helpline unionized, and they were all fired. They were replaced with an LLM-based chatbot, like we saw earlier, a lower-cost solution in the absence of humans. The chatbot used generative AI, so it had cool features like non-predictable outputs and values absorbed from the internet. What ended up happening was that when people with eating disorders texted in for support, instead of care, they were given something that looks to a machine learning model to be approximately the right thing, dieting advice. And this was not just triggering, but actively harmful. There are a lot of stories like this. A chatbot seems convincingly human enough to replace lawyers, doctors, teachers, but the ELIZA effect covers up ways in which they fall short of what a human would do. And these issues come to light in practice with sometimes disastrous consequences. This all brings us back to the question Weizenbaum attempted to answer in his book. What type of work should be delegated to machines? In spite of the huge progress that NLP has made in the last 57 years, this question is as relevant as ever. Weizenbaum wanted us to consider not just what NLP can be used for, but also what it should be used for. So, how do we apply this as we explore modern computing? So, maybe you look at this stack of technologies and you're like, this is not for me. I love security or theory or some other area of computer science. But these systems are becoming more and more ubiquitous in our world. And as a computer scientist, you will be one of the more informed consumers out there. So, when you're out in your life making decisions for policy or personal use, if you're considering using a chatbot to do something a human would otherwise do, I hope you'll keep this in mind, that the answer to the second question isn't always the same as the first question. And if you do become an NLP researcher and it's your job to explore this first question and expand the answers to it, in my humble opinion, but I believe Joseph Weizenbaum would agree, the most useful and exciting work that has the most impact and benefit to society is going to happen when people consider both of these questions in their explorations of modern NLP. They're not always obvious, but there are plenty of applications that actually fulfill this. I'd be so happy to talk about them with you, but I've already gone over time. So thank you so much for your attention. And I'm happy to take any questions or thoughts about this topic. Thank you so much. Feel free to email me. Great. Thank you.